Let's look at some types of strain gauges. Strain gauges can essentially be divided into two categories, okay? Uh, Unbonded strain gauges and bonded strain gauges. And we'll just look at those two types. Unbonded bonded strain gauge is basically the same as the wire that we just now saw, right? It's a piece of wire which is being stretched, and as it is stretched, the resistance of that wire changes. So basically, we have discussed it already. Let's look at one application of this. Now, take a look at this sensor, and what I would ask you to do is first look at this figure here on the right. So this is a displacement or a movement sensor. And if you look at this, so think of it this way. So this part, the internal part, is a movable piston, and the outward squarish kind of shape is a casing. Okay, so it's a casing, a fixed casing, inside which this movable part moves up and down. Okay, and as it moves, so if this movable part moves, let's say, into into the casing, what is going to happen? This wire and this wire are going to stretch, okay, while this wire and this wire are going to contract. And so, as these strain gauges are stretched and as the other strain gauges are compressed, their resistances change. And these change in resistances can then be used to actually measure the displacement. Does that make sense? Okay, so this is a displacement sensor which measures the displacement between the casing and this piston inside or the armature inside. Now we use this movement sensor, this displacement sensor, to make a pressure sensor like this. So if you look at the right part of this pressure sensor, this is basically the same displacement sensor that is here. Okay, and this displacement sensor, the armature of this displacement sensor is connected to a diaphragm here. Okay, what does that mean? So as the pressure then changes in this part of the sensor, this diaphragm is pushed, and as the diaphragm is pushed, the the uh, the armature is displaced, and the displacement can be measured using the strain gauges. Okay, as the pressure pushes the armature, the movement of the pressure, the diaphragm, is opposed by this connection that the armature has with the casing. So basically, there's a spring there. Okay, so what we are trying to do here is change force or pressure into displacement, right? And for whenever you want to convert force into displacement, what you do is you need to have a spring, because a spring is a device which compresses when a compressive force is applied, and therefore it changes the force into displacement. And when it is pulled, again it changes the force, the tensile force, into displacement. And so what's happening here is there's a spring between the armature and the casing, and this spring actually opposes the force that is applied by the pressure, and therefore converts the force. The force comes because of the pressure, right? Pressure times area is the force, and that force is being converted into displacement, and the displacement is measured by these sensors. So can you see how the movement sensor, the displacement sensor, is converted into a force sensor by use of the spring, and that force sensor is then converted into a pressure sensor by attaching it to a diaphragm. Is that okay? Okay, let's look at the next type of strain gauges, which are called bonded strain gauges. There's a reason why these are called bonded strain gauges, because these strain gauges are used by being bonded to a surface. Okay, so if you take uh, a surface like this, and you want to measure the strain when I apply a force here. So as I apply a force here, this is going to bend, right? So I want to measure the surface strains. So what I do is I take these strain gauges and I bond them or stick them on the surface. And as I stick them on the surface, they become uh, they they are deformed as the surface is stretched, and therefore they can measure the strain. Okay, so there are two kinds of bonded strain gauge, broadly speaking. One is metal foil um, strain gauges, and another is semiconductor strain gauges. The metal foil strain gauges are basically made up of metallic wires, which are usually in this shape. And this is a semiconductor strain gauge, which has basically a piece of semiconductor between 2 points. And as you can see here, as you apply force, let's say you pull on these two sides, the piece of semiconductor gets stretched, and that's the strain that the semiconductor would react to by giving a change of resistance associated with it. These metal foil uh, uh, these are the metal foil strain gauges, and it would be interesting for you to think about which direction are they going to be sensitive in. Of course, we have already talked about the advantages and disadvantages of semiconductor versus metal foil strain gauges, right? Semiconductor strain gauges are much more sensitive, but they are also much more sensitive to temperature, while metal foil strain gauges are less sensitive to displacement, but they are less sensitive to temperature as well. And that makes it much more stable in some applications. Okay, so here's our strain gauge, and we have put our strain gauge on a surface. Okay, now which direction is the strain gauge going to be? Um, is going to be more sensitive in? Now think of it this way. Now if this surface, if you take a surface like this, okay, and you bend it this way, so it is deforming this way, then what is happening? The strain gauge is being stretched. But if you bend it this way, if you bend it this way, the strain gauge is actually getting compressed, and that's what is shown in these two figures. Now and that's the direction of strain that these strain gauges can react to. Uh, so any strain in this direction, the strain gauges react to very well, because most of the length of the metal wires are there in that direction, and the wire gets pulled, right? But there's only a very little bits of wire here on the other direction, so it's almost not sensitive to stretch in this particular direction. It's mostly sensitive to stretch in this direction. Okay, another category of strain gauges that we can use are called strain gauge rosettes. These are basically combinations of strain gauges so that you can have sensitivity to strain in different directions. Okay, so as we said, this strain gauge here is only sensitive to strain in which direction? Vertical or horizontal? Of course, vertical, right? And this strain gauge is sensitive to stretch in the vertical direction. So what about uh, this particular rosette? Which direction would it be sensitive to? As you can see, probably all directions, right? So this strain gauge is going to be sensitive to direction in the horizontal direction. This strain gauge is going to be sensitive in the vertical direction, and this strain gauge is sensitive in the diagonal direction. So essentially, you have all the directions covered and a bit more. So if you have strain in this direction covered and in this direction covered, that kind of covers the entire plane. But you have put an extra strain gauge just in case, just to make your measurement a little bit more sensitive. I will leave you to think about the directions of strains for the other rosettes that are showed on the screen, and perhaps we could discuss it in one of the interactive sessions.